Hello and welcome to this workshop on sequences and series. Let's get right into it. So we're going to be starting with the arithmetic sequences. An arithmetic sequence is characterized by a constant difference between terms. So look at the sequence here, -2, 1, 4, and 7. As you can see that this sequence adds 3 to find each following term. So from the -2, we added a 3 to get the 1. From the 1, we added 3 to get 4. From the 4, we added 3 to get 7. The general formula for an arithmetic sequence is equal to Tn is equal to a plus n minus 1d. Tn is the value of the term at position n. A is equal to the first term. And n is equal to the term position, and this is the independent variable, where d is equal to the difference, and this can be found by saying t2 minus t1 is equal to t3 minus t2. Let's look at the following example. So we have the sequence 6, 3.5, 1, negative 1.5 going all the way to Tn. They want us to find the general formula of the sequence Tn. Let's see if we can do that. Remember, the general formula is given by Tn is equal to a plus n minus 1, common difference. All right, now what is a? It's 6 plus n minus 1. And what is the common difference here? We know it's minus 2.5. Now, we just write that in order. So this will be 6 minus 2.5n plus 2.5 because this multiplies n. So this will then be 8.5 minus 2.5n. This is our Tn. Now for number 2, which term has a value of minus 54? So all we need to do is, we need to say minus 54 is equal to 6, is equal to 8.5 rather. The 6 I'm getting it from the previous one. This should be 8.5 minus 2.5n. Then all we need to do is solve for n. So I'll swap these two. I'll have 2.5n is equal to 8.5 plus 54. Then we have 2.5n is equal to, let's quickly add those on our calculators. So 8.5 plus 54, that'll give us 62.5. Then we divide both sides by 2.5 to find n. Therefore, n is equal to 25. Now we're done with number 2. Now we need to check number 3. Determine by calculation whether or not minus 25 is a term in the sequence. So all we'll do is we'll say minus 25 is equal to 8.5 minus 2.5n. Then we have 2.5n is equal to 8.5 plus 25. Then 2.5n is equal to, let's check that on our calculators, 25 plus 8.5, which gives us 33.5. Then we divide both sides by 2.5. Then n is equal to, let's check that, 13 2/5, right? Now we need to check, is that a term in the sequence? No, it cannot be a term in the sequence. Why? Because 13 2/5 is roughly 13.4, and this is not a natural number. There you have it. Now let's look at the geometric sequences. So we have this example. This is the sequence 1, 2, 4, and 8. Right? So this geometric sequence is characterized by a constant ratio, and that constant ratio is given by T2 divided by T1. This must be the same as T3 divided by T2. This must also be the same as T4 divided by T3. If this does not hold, then the sequence is not geometric. Now, the general formula for the geometric sequence is Tn is equal to AR to the n minus 1, where A stands for the first term and R is equal to the constant ratio. Now, let's look at an example. Determine the general formula for the nth term of each of the following geometric sequences. Now, for number 1, we have that kind of a sequence, 1 over 2, 1 over 4, 1 over 8. We need to find the nth term. So remember, the nth term for geometric is Tn is equal to A multiplied by R to the n minus 1. Right? Now, what is our constant ratio? We need to find that. That will be what? T2 divided by T1. Let's quickly find that. And that gives us 0,5. Then, now we can substitute. We know that Tn is equal to A is the first term, 1 over 2, and our R is also 1 over 2. I just don't want to write it as a decimal, so I'll write 1 over 2 there to the n minus 1. And that will be the nth term of number 1. Remember, we cannot multiply these two because of that exponent up there. Now, let's do the same for number 2. We have to find R first. So R is equal to T2 divided by T1, which is 3x squared over x. And R is just 3x. Now, we know that Tn is equal to A multiplied by R to the n minus 1. What is our A? It's x. What is our R? 3x into the n minus 1. And that is the general formula for the nth term of number 2. Now that you understand what's going on, you can pause the video and try the following question. Now that you've attempted the question, let's see if you're on the right track. So they gave you a geometric sequence with second term 1 over 2 and ninth term 64. A, they want you to determine the value of R, they also want you to find the value of A, and also they want you to determine the general formula of the sequence. So let's quickly do that. So the second term is 1 over 2. We know that T2 would be equal to A to the power, A multiplied by R to the power of 1, right? Now, we know that T2 is a half, so I'll say 1 over 2 is equal to A R. Furthermore, I know that the ninth term is equal to 64, so I will say T9 is equal to 64. But what do I know about T9? T9, right? So I'll say 64 is equal to AR to the 8. Then what I can do is make these equations. I'll make that equation 1 and I'll make this equation 2. Then I will say equation 2 divided by equation 1. Then this means I have 64 is equal to AR to the 8. So this is divided by 1 over 2. And this side it's divided by AR. So 64 divided by half will give me 128. And then the a's will cancel here, and I'll be left with 7. All right, now I just need to find the 7th root of 128. Okay, let's quickly find that on our calculators. And that gives us 2. So R is equal to 2. Now, we found the value of r. So what we can do is find the value of a by substituting the r value into either equation 1 or equation 2. So I will say 1 over 2. I'll substitute into equation 1. So 1 over 2 is equal to a multiplied by 2. So I'll divide both sides by 2. Then I know that a is equal to 1 over 4. Now they're saying determine the general formula for the sequence. So we know that Tn is equal to a r to the n minus 1. So this will be Tn is equal to, what is the a value? 1 over 4. What is the r value? 2n minus 1. There you have it. Now let's look at the second one. So we have k minus 4, k plus 1, m, and 5k. They're saying if the first three terms form an arithmetic sequence and the last three terms form a geometric sequence, determine the values of k and m if both are positive integers. Now, we know that this will be term 1, that will be term 2, and this will be term 3. And these form an arithmetic, right? So let's do this. So we know for arithmetic, let's just put them in order. K minus 4, k plus 1, with a semicolon there, and m. For arithmetic, we know we have a difference, right? So T2 minus T1. So I'll say k plus 1 minus k minus 4. This must be equal to m minus k plus 1. Then this will be what? K plus 1 minus k plus 4 is equal to m minus k minus 1. Then we know that this k is going to cancel that k. 1 plus 4, so that'll be 5 is equal to m minus k. Then I'll take this one over to the other side, so I'll say plus 1 there. So I have 6 is equal to m minus k. I can decide to solve for 1, so 6 plus k is equal to m. That's all we can do for arithmetic sequences for now. Now let's look at the geometric part. So we know that r is given by T2 divided by T1, right? So T2 is m, T1 is k plus 1. This must be equal to 5k over m. Then we cross multiply. M squared is equal to 5k into k plus 1. So m squared is equal to 5k squared plus 5k. Now let's see. Now remember, we have m here from the arithmetic. We can quickly substitute that here. So we'll say 6 plus k, but remember it was squared, is equal to 5k squared plus 5k. So this will be 36 plus 12k plus k squared is equal to 5k squared plus 5k. Then you can just bring everything to the right hand side. So 0 is equal to 5k squared plus 5k minus k squared minus 12k minus 36. So 0 is equal to 4k squared, this and that. Then we have minus 5 minus 12, that'll give us minus 7k. Then we have minus 36. Then we try to factorize that. So 0 is equal to, let's check. So we'll have 4k there and a k there. Now this one has to be positive, the other one has to be negative. So now we're looking for the factors that can make 36 and 7. So we will have 4 there, and a 9 there. Let's see if that works. First, outer, inner, and last. Yes, that works out. So k is equal to minus 9 over 4, or k is equal to 4. Now, we know the value will be 4 because they said positive integers, right? Now, we'll take k is equal to 4. Then we need to substitute that into this equation here to find what m is. So, if I do that, I'll say 6 plus 4 is equal to m. This means that m is equal to 10. Congratulations for getting the right answer there. Now let's carry on. Now we're going to be looking at series. What is a series? So a series is the addition of a sequence of numbers. So a series is given by Sn. This just means this is equal to the sum of the first n terms in the sequence. This is a series. Now, suppose we have T1, T2, T3 going all the way to Tn. If we add those terms there together, if we add them together, this will give us Sn. Now let's look at the finite series. If we summate a given or certain number of terms, that series is said to be finite. Consider 1, 4, 9, 16, 35 going all the way to Tn. If we take the sum to 4 terms, so all we're doing is we're adding term 1, 2, 3, and 4 together. This will give us 30. This is an example of a finite series since we are only adding or summing a finite number of terms. And in this case, we've added 4 numbers together. Now let's look at the arithmetic series. So the general formula for an arithmetic sequence is given by Sn is equal to n over 2 into 2a plus open bracket n minus 1 close bracket multiplied by d close bracket again. Right? So remember, Sn just stands for the sum of the first n terms. A stands for the first term. N stands for the number of terms that we are adding up to. D is the common difference. So it's given by T2 minus T1, which is equal to T3 minus T2, and etc. Now let's look at the geometric series. So the general formula for a geometric series is Sn is equal to a into r to the power of n minus 1 all over r minus 1, where Sn is equal to the sum of the first n terms. A is equal to the first term, and n is equal to the number of terms that we are adding up to. R is the constant ratio, and that is given by T2 over T1, which must be equal to T3 over T2, which must also be equal to T4 divided by T5. If that does not hold true, then it's not a geometric series. Now let's look at the infinite series. An infinite series is the summation of all possible numbers in a sequence. Although we keep adding numbers, this summation does not always equal infinity. If an infinite series is equal to infinity, we say it diverges. If an infinite series is equal to a certain value, we say it converges towards that value. Arithmetic series always diverges as it always turns to positive or negative infinity. Now let's look at a convergence test for geometric infinite series. So if you have your r being between -1 and +1, then the infinite geometric series converges. If r is less than -1 or r is greater than 1, then the infinite geometric series diverges. Now, the sum to infinity will be given by a over 1 minus r, but this must hold true. R must lie between -1 and +1. Now, let's look at the arithmetic series. They're saying Johnny decides to spend 2 weeks getting fit. On Monday, he runs 2 kilometers. He decides to run 0.5 kilometers further each consecutive day. How far does Johnny run in total in the 2 weeks? Then, let's see. So the first time Johnny ran, he ran 2 kilometers. Then he added by 0.5 kilometers, so that was 2.5. The third day, this was 3. The fourth day, this will be 3.5. Now, because they want to see how far he runs in 2 weeks, so we need to add these together, right, to 14 days, because 14 days are 2 weeks. So remember, our A is equal to 2. Common difference is equal to, yes, you guessed it right, 0.5. Then, now let's use the formula. Sn is equal to n over 2 into 2a plus n minus 1 multiplied by d, close the bracket. So, what else do we know? We know that n is 14 over 2. Then 2, what is the a value? It's 2. Plus n is how much? 14. So we'll say 14 minus 1. What's the common difference? 0.5. And then let's quickly solve that. So this will be 7 into 4. Remember, this is minus 1 there. So plus 13 multiplied by 0.5. Then let's quickly check that on our calculators. So we have 7 times 4 plus 13 times 0.5 . And that gives us 73.5. And it means that he runs a total of 73.5 kilometers in the 2 weeks. Now let's look at the geometric series. Johnny decides to spend 2 weeks getting fit. On Monday, he runs 2 kilometers. He decides to increase the distance he runs each day by 5%. How far does Johnny run in total in the 2 weeks? So, the first day, he ran 2 kilometers, right? The second day will be 2.1. The third day will be 2.205, because he increases it by 5% of the previous one. Okay, let's look at the geometric series. Johnny decides to spend 2 weeks getting fit. On Monday, he runs 2 kilometers. He decides to increase the distance he runs each day by 5%. How far does Johnny run in total in the 2 weeks? So we need to find the first few terms. And I usually like to find the first 3. So we know that he runs 2 kilometers on the first day. Then on the second day, he would increase that by 5%. And that will give you 2.1. And on the third day, you'll increase the previous day by 5%. So this will give you 2.205. Now let's find R. This is T2 divided by T1, which is going to give us 1.05. Now we need to find the sum. So Sn is equal to A into R to the n minus 1, close the bracket, over R minus 1. Remember, he runs for 2 weeks, and that is a total of 14 days. So we have 2 into, what is R? 1.05 to the power of, yes, 14 minus 1, close the bracket, over 1.05 minus 1. Then all we need to do is check this on our calculators. Let's quickly do that. So we'll have 2 into 1.05 to the exponent 14 minus 1, then divided by 0.05, and that would give us 39.20. And those are the kilometers that Johnny runs in 2 weeks. Now let's carry on. Let's look at the infinite geometric series. Johnny has become incredibly fit, and he decides he's going to run less and less each day for the rest of his life. On day 1, he runs 20 kilometers. Each day after that, he runs 95% of the distance he ran the previous day. If Johnny lives forever, how far will he run in total? Okay, so we know that on day 1, he ran 20 kilometers. Then on day 2, he's going to run 95% of the 20 kilometers. And let's quickly check what that is on our calculators. That will give you 19. Then we know on day 3 is going to run 95% of the previous day, which is day 2. So let's quickly check that on our calculators as well. And that will be, and that gives you 8. Now we have the first 3 terms. Now let's find the sum. We know that this is going to be the sum to infinity, and this is a over 1 minus r. Now let's check. What is a? It's 20. 1 minus r. Let's quickly find r, and we know that'll be 19 over 20, because this is t2 divided by t1. Let's quickly check that on our calculators. So this will be 20 divided by and that gives us 400 kilometers. Now that you understand what's going on, it's now your turn to pause the video and try the following question. Now that you've attempted the question, let's see if you are on the right track. So they're saying calculate the values of x for which the series converges, and they gave you that series there, right? Now all we need to remember is for a series to converge, this needs to hold true. So r must lie between -1 and 1. Now let's find r first. We know r is going to be t2 divided by t1, which is 2x plus 1 over 1. So this means that r is 2x plus 1. And you can check this by taking t3 divided by t2, and that'll quickly, if we can do it real quick here, so that'll be 2x plus 1 squared over 2x plus 1. That's a 2 right there. Then remember this is squared, so we know that this is going to cancel 1 there. So r is true, it is 2x plus 1. Now all we need to do is substitute r here. So we'll say -1 into 2x plus 1, 1. Then we need to subtract 1 throughout. So we'll have -2, 2x, and 0. Now divide everything by 2. So we'll have, if I divide by 2 there, we'll have -1, x, and 0. So for the series to converge, x must lie between -1 and 0. Now let's look at sigma notation. What is sigma notation? Sigma notation is a shorthand instruction for us to add up a specific series of terms in a sequence. Now, this is the sigma symbol, right? Then we have a function, there it is, that is going to help us find the first few terms. So we have the function of n is equal to 2n minus 1. Now, this simply means what we need to do is start at 4. That's the starting point. So we have to substitute 4 into the function there and find the first term. Then keep going on and on until we stop at this value up there, which is 10. So n is the starting point and 10 is the end point. These are the ones that we substitute into our linear function there. Then all we do is we'll find this, remember, is the first term. We'll find the first few terms. Right, find those. So we start with 4, then go to 5, then add up all the rest, then go to 9 and stop at 10, but including 10. Don't forget to include the 10. Once you have those, then you'll add them together. More on sigma notation. We can use series formulae for sigma notation. Now, remember, this is the linear function and we'll use the arithmetic series there. Remember, if it's arithmetic, Sn is going to be equal to n over 2 into 2a plus into n minus 1, close bracket d, close bracket, where a is the first term. Remember, how do you find the first term? You substitute 4 into the linear function. Then you find the first term, and then the common difference, right? And that is given by T2 minus T1. So this means you have to sub in the next value to find what T2 is, then subtract the first term to find what D is. And remember, N is the end part. That is the end point. Now, let's carry on. We can use series formulae for sigma notation. Now, remember, this is an exponential function, so we can use the geometric series here. And we know the sum for geometric is Sn is equal to a into r to the power of n minus 1, close bracket, all over r minus 1, where a is the first term. So we'll substitute minus 4 into our function there to find the first term. Then r is given by T2 divided by T1. How do we find T2? We substitute the next value. If the first value there is minus 1, so the next one will be n is equal to minus 3 because we are going to 5. So once we substitute this minus 3 into the function there, we'll get T2. Then to find our r, we'll say T2 divided by T1 to find our r. And n is the end point. So remember, we can't always use series formulae for sigma notation. Look at this one here, right? So we have n squared. It's neither linear nor exponential. So we calculate each term by hand and add it all up. So if we had this guy there, so all we have to do is start where n is equal to 1, right? So we'll have 1 squared, then make n 2, 3, 4 until we reach 5. Then after we have those, we need to add them all up and find the value of sigma, or the sum. Now it's your turn to pause and try the following question. Okay, now that you've paused the video and attempted the question, let's see if you are on the right track. Now, they're saying find the value of, and then we have the sigma symbol, then k is minus 2, and we have to go all the way to 5. Right? So we need to check how many terms those are. And they also give us a function there, 3 to the k. So let's quickly do that. So we'll have 3 to the minus 2, 3 to the minus 2 plus 3 to the minus 1 plus 3 to the 0 plus 3 to the 1, 3 to the 3 plus 3 to the 4 plus 3 to the 5. Now let's check. Now we have all the terms there, right? Let's quickly check. Now this will give us 1 over 9, and this will give us 1 over 3, and this will just give us 1. Now we need to check what r is, and r is given by T2 divided by T1. Let's quickly check that. And that gives us 3. Now, let's see, how many terms do we have? 1, 2, 3, 4, 5, 6, 7, and 8. So this means we're finding the sum to 8 terms. So Sn is equal to a into r to the n minus 1 over r minus 1. Now we know what a is. It's 1 over 9 into r we found to be 3. To how many terms? 8 terms minus 1. Close that bracket, and then we know that r is 3 minus 1. Then all we need to do is find this on our calculators. Let's quickly do that. And the answer there that we have is 364 and 4 over 9. Now let's carry on. Now it's your turn to attempt this. And now that you've attempted it, let's see. So remember, we need to find the first few terms as well. So we'll sub ni to be 1. So we have times 2 to the 1, then plus 3 times 2 to the 2, plus 3 times 2 to the 3, plus this all the way to 3 times 2 to the power of m, right? Remember, we've been asked what is the greatest integer value of m for which this holds true. So this must be less than 511. So all we need to do there is add these together, right? Now remember, here we have 3 multiplied by 2, it will give us 6. Then 2 squared is 4, multiplied by 3, 12, and here 2 to the 3 is 8, multiplied by 3 is 24. So our r we know is T2 divided by T1, which will give us 2, because 12 divided by 6 will give us 2. Now let's use the sum formula. So Sn is equal to A into r to the n minus 1 over r minus 1. Then what is our A value? It's 6. What is r? 2. Then n would be m minus 1 over, let's close the bracket up there, then this is over r, which is 2 minus 1, right? So we're going to equate this to 511 and then try to solve for m. Now we know, just carry on up here, now we know that 2 minus 1 will give us 1, and then we will cross multiply. So we're going to have 511 is equal to 6 into 2 to the m minus 1, close the bracket, divide everything through by 6 there. Now let's check that on our calculators. Now what do we have here? We have 85, and 1 over 6 there is equal to 2 to the m minus 1. Now we'll take the 1 over to the other side. So we'll have 85, and 1 over 6 plus 1 is equal to 2 to the m. And let's quickly check that. Then we have 86, and 1 over 6 is equal to 2 to the m. Now remember, we can apply logs to solve that. So we know that log of 86 and 1 over 6 is equal to m log of 2. Then you divide both sides by log of 2, and these will cancel on the right hand side. So we know that m is equal to log base 2 and 86 1 over 6. Now we just need to find that on our calculators. Let's quickly do that. And that gives us an answer of m is equal to 6,4, right? So the greatest integer value will be m is equal to 6. Now we can check this by plugging m back into our function there. So if we know that m is equal to 6, so this means that we are stopping where m is equal to 6. Because if we check for 7, we'll see that it's actually greater than 511, right? So we can take the sum to 7 terms here and find what the value is going to give us. And we can quickly do it here. So the sum to 7 terms would be a, which is 6 into r. It doesn't change, it's 2. But instead of saying m, we're going to plug in a 7 just to check. Minus 1. Then this is 2 minus 1, which is just 1. Let's quickly check that on our calculators. And as you can see, this value gives you 762. But what would happen if we change this from a 7 to a 6? Let's quickly check. So if we say 6 into 2 to the 6 minus 1 over 1. Let's quickly check that on our calculators. So 6 into 2 to the 6 minus 1. And that gives us 378. And now we know that m is equal to 6. And that is it for the workshop on sequences and series. I hope you enjoyed.